question tells us how y change when x change. The formula is dy over dx.
So dy over dx means the rate of change?
Yes, it shows how fast y change for a small change of x.
Oh, just like the slope of the graph?
Exactly. If y equals to fx, then the derivative is f prime x equals to dy over dx.
Oh, I see. Three.
I have to do nothing. I have class after
Okay,
this. Bye. Have you learned the differentiation technique from our calculus now?
A bit. I saw something about differential, but I don't really get it.
Differential are easy. Let me show you how. If we have y equals to fx, then the small change in y is dy equals to f prime x dx.
So dy is just the derivative multiplied by dx.
Yeah, and we can use that to approximate values. The formula is
So that's how we estimate new values of a function.
exactly, and we also learn related rates. That's when the two things change with time.
Right. So when both x and y depend on t.
Yes, we can use chain rule.
So the steps are choose the formula, differentiate, substitute values, and solve.
Correct. That's the main technique from the chapter.
Our first function is y equals to square root 2x minus 1 sine 3 minus x. This is clearly a product of two functions, so we must use the product rule, which is dy over dx equals to u v prime plus v u prime. First, let's define our part. Let u equals to square root 2x minus 1 and change the square root to 1 over 2. Then let v equals to sine 3 minus x. Now we find the derivative u prime and v prime using the chain rule. For u prime, we bring down the exponent 1 over 2, subtract 1 from the exponent and multiply by the derivative of the inside, which is 2. So u prime equals to 1 over 2, 2x minus 1 to the power of negative 1 over 2 times 2. The answer will be 2x minus 1 to the power of negative 1 over 2. And we bring negative 1 over 2 become 1 over square root 2x minus 1. V prime equals to cos 3 minus x times negative 1. So the answer is negative cos 3 minus x. After that, we're applying the product rule. We combine them to dy over dx equals to u v prime plus v u prime. So the answer is dy over dx equals to square root 2x minus 1 times negative cos 3 minus x plus sine 3 minus x times 1 over square root 2x minus 1. After that, simplify and combine the terms over a common denominator, square root 2x minus 1. The first term is negative square root 2x minus 1 cos 3 minus x. The second term is sine 3 minus x over square root 2x minus 1. To combine the first term, we multiply it by square root 2x minus 1 over square root 2x minus 1. dy over dx equals to negative square root 2x minus 1 cos 3 minus x times square root 2x minus 1 over square root 2x minus 1 plus sine 3x over square root 2x minus 1. So the final answer is dy over dx equals to sine 3 minus x over square root 2x minus 1 minus square root 2x minus 1 cos 3 minus x. For question B, the question is y equals to ln 5x plus 1 over cos 2x. This is a quotient, so we must use the quotient rule, which is dy over dx equals to v u prime minus u v prime over v squared. We define our part, let u equals to ln 5x plus 1 and then let v equals to cos 2x. Now we find the derivative u prime and v prime using the chain rule. For u prime, the derivative of ln something is 1 over something times the derivative of the inside, which is 5. For u prime is equals to 1 over 5x plus 1 times 5. The answer is 5 over 5x plus 1. For v prime, the derivative of cos something is negative sine something times the derivative of the inside, which is 2. So v prime is equals to negative sine 2x times 2. The answer is negative 2 sine 2x. Then we substitute this into the quotient rule formula. dy over dx equals to v u prime minus u v prime over v squared. dy over dx equals to cos 2x times 5 over 5x plus 1 minus ln 5x plus 1 times negative 2 sine 2x over cos 2x squared. Next step is to clean up the numerator. The first term is 5 cos 2x over 5x plus 1. The second term is negative ln 5x plus 1 times negative sine 2x, which is simplifies to 2 ln 5x plus 1 sine 2x. The denominator is cos squared 2x, so dy over dx equals to 5 cos 2x over 5x plus 1 plus 2 ln 5x plus 1 sine 2x over cos squared 2x.
The given equation is 2y ln 4x plus 3x to the power of 7 equal to 2tan x minus y minus e the power of x squared. Since y is mixed inside several functions, we cannot separate it easily, so we differentiate both sides with respect to x. First, we differentiate each term one by one. For the first term, 2y ln 4x is a product of two functions, so I use the product rule. The derivative becomes 2y times 1 over x plus 2 ln 4x dy over dx. For the second term, 3x the power of 7, this is straightforward differentiation, 21x the power of 6. Now moving to the right side, for 2 tan x minus y, we use the chain rule because the tangent function has x minus y inside. Derivative of tan u is sec squared u times u prime. 2 sec squared x minus y, 1 times 1 minus dy over dx. For the last term, negative e the power of x squared, again, we use the chain rule. Derivative of e the power of x squared is e the power of x squared times 2x. So, negative 2x e the power of x squared. Next, I substitute all these results back into the equations. Then, I expand the right hand side and collect all dy dx terms on one side. Dy dx equal to 2 sec squared x minus y minus 2x e the power of x squared minus 2y over x minus 21x the power of 6, all of them over 2 ln 4x plus 2 sec squared x minus y.
For this equation, I'm using differentials to approximate two expressions that involve the number 63.98 because 63.98 is very close to 64, which is much easier number to work with. I want to estimate the square root of 63.98. Start by defining the function fx equal to square root x equal to x to the power of 1 over 2. At the base value x equal to 64, the exact square root is n. So next, I differentiate the function. The derivative is f prime x equal to 1 over 2 square root x. When I substitute x equal to 64, I get f prime 64 equal to 1 over 16. Now, I find the small change, which is this dx. Since the actual value is 63.98, the change is dx equal to 63.98 minus 64, which is negative 0.02. So using differentials, df equal to f prime x dx equal to 1 over 16 times with negative 0.02, which give approximately negative 0.001. So the estimated value of value of square root 63.98 is 8 plus negative 0.001 equal to 7.999. So for the final answer, I subtract the two approximations, which is 7.999 minus 1.000 equal to 6.999. So the final estimated result is 6.999 when using differentials.
In conclusion, differentiation helps us understand how things change. It is an important tool in mathematics because it lets us find the rate of change and solve real-life problems in science, engineering, and economics.